about edge detection and added plugins for automated bin picking. You will learn about robotics automation, how it can help you achieve better efficiency in bin picking applications. Just a little housekeeping before we get started. A recording of this training will be emailed you following today's presentation. Also, feel free to ask questions at any time during today's webinar by typing your questions into the Q&A section in the control panel. We will take some time at the end of today's presentation to address as many questions as time allows. Lastly, please place your webinar display in the side-by-side view as shown on the screen. Our presenter will be showing you a PowerPoint as well as a live video during today's presentation. Now, without further ado, we will turn our time over to our presenter, Nick Longworth. Nick is a senior robotics engineer for 6 sensor and safety integration team. He has over 7 years of experience in the automation engineering and machine building field. With that, Nick, please take it away.
Thank you, Lisa. All right, I hope everyone's doing well today. I'm going to go a little quickly here. We have a lot to cover in the next hour. So first, I'm going to give you guys a general overview of PLB, what it means, what it is, what we offer, all that fun background stuff. I'm sorry if some of you have seen it before, but for those of you who haven't, that's what I'm doing first. After that, I'm going to go through each of the algorithms we're looking at today, just individually. I'm going to show you that the robot can actually make it and get there. My robot is already aligned with the camera, but I will walk through just general steps of setting up the job. After that, I am going to go back to a CAD-based job for the part I'm working with and just show you guys the robot running full speed so you can see how everything works in the end of the job setup. So first thing is, what is PLB? So it means part localization bins. It doesn't have to be in a bin. You're seeing me use a bin today. It really just is anything that could use a 3D robot guidance effort for that application. So if you're using palletizing, if you're using a tray and a foundry, if you're using bins, it'll work for all of it. We just call it a PLB because originally it was for bins. It's kind of evolved since then. Next thing, we have several different cameras that work with our system. So one of our nice features here is that we're not going to force fit a camera to your application. We have the ability to change out our cameras via what the application is, and I'll explain that more in a minute. After that, though, PLB itself is just a software package that's going to be running on your computer. That software package aligns with one of our cameras, but it is just a software package on your computer. So there's many algorithms, and there's very easy integration with the robots. So this is what a general system will look like from an architecture standpoint. You're going to have your application. You'll have a vision sensor. That's going to be one of our vision sensors that we sell you. It will be licensed. That's when we sell it to you, the license comes on the camera. It's going to be plugged directly into a computer. That computer is then going to be working with the controller of the robot, whether that's a Fanuc robot, KUKA, ABB, whoever you are. Doesn't matter. We do have samples of that code, though, so we're not just kind of leaving you out in the dark. We will be able to give you samples of how to communicate with your robot. So PLB engine. These are kind of our nice things here. Like I mentioned before, on the image acquisition side, we have multiple cameras. We also have a modular approach to the object detection and localization. That is our different algorithms. I'll be getting to those in a minute here, but we have several different ones, or you could write your own. Next piece is hand-eye alignment. That's where the robot will actually align itself with the camera. That way we can give you absolute offsets instead of a relative offset. It makes your life easier in the end. We also have template-based communication. So we don't force the application, the communication that you're going to use for your application. You can change what parameters you're getting to whatever you want them to be. There's not a set communication template. So cameras. These are the 3 cameras that we currently sell. We do have others that are available, but they're not something that we're selling at the moment. If we ever had an application, we would do them. Now, the PLB 500s are scanning rulers. That's what we're going to be looking at today. So that is a laser triangulation camera. It's going to sweep a laser across the volume of view, and it's going to watch the deformation of that laser with the camera that's inside of it. So again, that's what we're working with today. This one has a very big volume of view. It's a 1 meter standoff, and then you have a 1 meter volume of view below that. Because of the angular nature of this, that is a growing volume of view. So at the top of that 1 meter volume, you're getting about a 1200 by 800 field. At the bottom, you're looking at about 1600 by 1780 field. It's pretty big at the bottom. And you're getting pretty good resolution, 1 to 4 millimeter resolution, so plus or minus half, and plus or minus 2 millimeters at the bottom. The main thing with this one, though, is you get low image noise. We're not going to see a whole lot of noise in the image, a whole lot of artifacts or anything like that. And we're very resistant to ambient light because we're just looking at that laser as it comes across. We're not working with a projector or anything. So it's very good for varying light conditions and stuff like that. The other nice feature of it is IP65. So you foundries out there, this guy works well. It doesn't get dust in it or anything like that. The PLB520, that's one of our structured light cameras. It has very high resolution. It's what we use for bolt picking or something like that. I did a webinar recently, if you look on YouTube, about bolt picking with this one. We sell this in 3 pre-calibrated units. You could calibrate with your own volume of view. It's flexible, so there's a lot of different applications you can do with it. The main thing is it's going to be high resolution, so you can really see those details of your part. The last one is the Visionary S. And this one's a little lower resolution. It's still structured light. It's in the IR space instead of the blue light space like the 520. The main thing, though, is it's quick. It's at 30 frames per second. So logistics applications, if you're looking at box picking, bag picking, depalletizing, anything fun like that, this is probably going to be the one we look at, is going to be this Visionary S, because it's able to keep up with the speed. Whereas the other ones may be a little slower. You can get the 500 down to maybe 2 or 3 seconds. You can get the 520 into the half second to 1 second range, but it's not going to rival the Visionary S and the, very, very quick in the 30 frame per second range. So all those cameras work with PLB. It's just an image acquisition module pretty much. So your PLB is always going to look the same regardless of the camera you're using. It's always going to have these features. It's always going to have the same inputs and outputs as you see here. One quick note on the licensing. So the licensing comes with the camera. If we have 2 tiers of licensing, one has CAD matching and one does not. That changes your price a little bit. You'll get a lower price if you're not doing CAD matching. And you'll see today you don't always need CAD matching. If you have a somewhat structured bin, maybe an easier application, we might not need CAD matching, and that gets you a nicer price. So next thing here, you got the different algorithms that we actually have built in. First is the surface algorithm. That's going to be our CAD matching algorithm. So if you have a complex part that has a lot of features on it and it doesn't really have a primitive that you can pick out, then this is going to be the one you want to use. So you'll see today I'm actually doing a connecting rod too. I'm going to use a couple of different plugins to also work with that application. But if I want to pick this connecting rod from any possible orientation, it's going to be on a CAD matching algorithm. I'm not going to be able to do that with a plugin. But if I have a more structured bin where I can assume they're laying down, I might not need CAD matching. So next thing is Edge. This is one of the ones we're going to go over today. Edge is basically when we're just looking for almost like a pattern match, but in 3D. So it only supports a 15-degree tilt. Generally, it can be used to supplement the CAD algorithm, or if you have a very featureless surface, it can be good. Really depends on your application, like I said. Next thing is flat region. Our flat region algorithm is just looking for boxes. When it looks for those boxes, you define a range. So you can really decide, if you have 3 different sizes of a box, it'll find all 3, and it'll also tell you which one it found. You can send the bounding box profile out, so it knows exactly how big the box is that it found. That way you could sort them based on that. But it will find a box within a range. So very good for logistics, parcel singulation, all that fun stuff. Circular shape is another one we're going to be doing today. again, just looking for a primitive. Just like a flat region, we're looking for a box, a rectangle. In circular shape, we're looking for a circle. So if you have a primitive circle somewhere on your part, in this case, this connecting rod, there's a nice big circle right in the middle. We can find that. Next one is predefined box. This is very similar to the flat region. The only difference, really the main difference here, is that it's looking for a specific rectangle rather than a range of rectangles. So it's very good for, say, ingots. We do a lot of ingot applications with this particular algorithm. It's also good for boxes if you're looking for a specific one, or just depalletizing. Break disk, I'm not going to go over break disk today, but it's generally the same thing as the circle algorithm. You're just looking for a bunch of circles. In this case, they're stacked on top of each other, and there's some surface involved as well. We do have another plugin coming out just before I move on here called Pipe. So where we're looking at just for a piece of pipe. So we look along the surface of it and combine some lines and look for that max peak, and it gives us a nice clean profile of that pipe. It's in beta right now, so it's something that's coming out and we would be able to use for an application if you have one. So integration with the robot. Everything is TCP/IP. I apologize. I guess I lost my audio.
Oh, I'm glad you're back.
Yep, I'm sorry about that. So let me back up here. So where I lost audio. I'm going to go ahead and start with the edge algorithm here. I apologize if you guys missed a little bit of the presentation there. So we're going to start here. The edge algorithm is going, I've already got my bin set up here. So I'm going to go ahead and show you guys just every little piece it takes to set up this job, and then we'll move forward from there. So I already have my bin set up in here. I got my top wall thickness, which is how I'm actually going to determine my my rim here.
Nick, I believe you'll need to share your PowerPoint again or your video. Right now we just see.
Okay, you got it. There we go.
Perfect.
There we go. Okay.
Yep.
Sorry about that. All right, so I already have all the dimensions in here for my bin. I've zeroed this out at this point so that it does not have a transform built. The top wall thickness is going to be how it actually finds the rim here. So when I click this button, though, it's going to go ahead and actually find the bin for me. So I don't actually have to go and set my transform and manually move this around. It's going to go ahead and find it and set it up. So all I have to do is put my bin size in, and then I'm good to go. So next thing, I'm going to jump in here into my edge algorithm, and again, I'm going to redo this a little bit. So if I take an image right now, you guys will see I have a lot of parts in here. So I'm going to go ahead and rearrange these parts, because when you're doing an edge algorithm, you're looking to basically get a single part to be able to create a reference from. So I'm going to go ahead and actually dump these. But put just one right there. So when I go back to this localization tab, I'm going to go ahead and click this button right here. That's going to take an image. I'm only going to get one part in that case. And you see, my old one did not line up that I was using before. So I'm going to go ahead, and this button over here will allow me to get to some controls. Go to my teach section, and this blue plane is what I'm looking at for my my pattern reference. So I'm going to create a cross section of the part by lowering this blue plane. So when I zoom in here, then I can start to actually see what I'm looking at here with the part. And then I'm going to go ahead and brush it. And so I'm going to use a circle brush, and I'm going to make it a little bit bigger here. And then we just brush our features. And you'll see I create some edge features there, and I have some surface features here as well. And what will happen is if I wanted to get more surface features, I could say lower my resample resolution. And you'll see I start getting more of these little dots on here. Those are my surface features. And if I want to get more edge features, I could do the same thing where I'm, say, dropping this down, and I'm starting to get more edge features. I'm actually okay with this 1.5, so I'm going to remove that back to there. Depending on your application, it will change what you need. But that's how I teach my edge job. That's all I need to do to teach my edge job. There's nothing else to do there. So there are some other things here. You can change your score threshold, along with there's the blacklist, which basically the blacklist is if you find a part and that part doesn't move during the next image, but it had reported it to the robot and your blacklist is turned on, PLB will basically say, okay, I reported that part, it didn't move, so I'm pretty sure something kept you from picking it up, so I'm not going to report it again. You can clear that from the robot. So normally it would be in a case of maybe the robot can't actually reach it, so it moved on to the next localization. Then maybe 5 parts down the road, you clear the blacklist and you allow it to find it again to see if maybe you can reach it now. Maybe it moved a little bit because you pulled some other parts out. So some of those more advanced things going on there. Next thing you'll do is you'll bring in your gripper. You see this gripper matches what I have with my robot. It also matches my tool center point. So my tool center point is taken on the very tip of this gripper, just like you see this coordinate system. And it's shown as a with the orientation. The orientation does have to be correct as well. I do have a version of this that's open and closed. You can have as many versions of your gripper as you want. So if you had a magnet, if you had fingers, if you have suction, you can change between all those. You can put all of them in here, and depending on which pose uses what, it would tell you which one you're supposed to use. So in this case, I have my demo here. I've disabled some of these poses. I did copy this from my my Cad algorithm. So I have this pose enabled right here. This is the only one I have enabled. And so right now, it's based on my original reference image. So I'm going to go ahead and change this. So I have it as my opened one. I'm going to turn on my local transform. You see this coordinate system where my TCP comes up. And then I'm going to go ahead and shift it over and get it in the right spot for this particular pick. This is just a little bit of movement. And we'll move forward here. Now I'm just going to pick it right on the neck of this here. All right, so let me move it down a little bit. And that's really all we need to do to be able to set up a pick point. There's not much to that. So now we have our bin, we have our pick poses, we have our localization. We should be good to go. So I can go ahead and lock my job. I can go into my analysis mode here. And this is where I can actually see if what I did works. And I'll get some feedback on it. So I'm going to go ahead and take a picture again. You'll see this laser come across. I'm going to localize my bin. And I'll bring up my break part localization, my breakpoint localization. So I'll be able to run through it step by step. I have a localization step. I can check collision, and then I can look at all steps. So when I click localization, you'll see I'm able to find this part. Hopefully I'm able to find this part because it is my reference image. That's always a good sign. I'm going to go ahead and hit collision. It's going to actually show me what's going on with this particular gripper. It gives me, if I have more than one pick pose, I'd be able to see everything here in terms of how many points of collision it has. And if I hit all steps, it would be just like hitting this button. And I'd be able to see the gripper come through. So now I can go ahead and throw a few more parts in there. We can see what happens. And again, edge is only going to support 15 degrees of tilt. So if I were to tilt these parts too much, I may not be able to find them. So we'll go ahead again and localize our bin. We'll localize a part. We're able to find stuff. So as you can see, this one's up on a tilt. And we're able to work our way through and find a whole bunch of different parts. So I'm hitting this next localization, and that's what it's finding. So this one, it wouldn't actually pick because it's underneath the other part. It would end up using the collision avoidance to not pick that one. So if I go to collision, you'll see where it's now got 5 points of collision, I have in my pick point here allowed for 20 points of collision. So 5 will still pass in this case. I do pass multiple points to the robot. I'll pass 5 different points, you'll see. There will be one above the bin. It'll be 100 millimeters above the bin. I'll have an approach pose to the pick point. I'll have the clear pose from the pick point and the exit along with the pick point itself. So you see that. If I actually run the full localization, this is the one it's going to choose. And it's choosing it based on score at this point. There are ways to work around that, but at the moment I have it actually showing up via the score. So we do have other things we can do with this to enable more in the application. We could split our bin in half using zones. That would allow us to pick 2 parts per image. We can do this up to maybe 16 parts per image. Basically, in this idea of zones, we're going to split the bin up and say, okay, I know that if I pick from this zone, more than likely it's not going to disturb anything from the other. In this case, I can't say that with this part, so I'm not going to split my bin up by zones, but in other applications it may help. So beyond that, that's how you set up the edge algorithm. It is a very easy algorithm to use. I'll go ahead and run the robot with it real quick here so you guys can see that it does in fact pick up the part. One moment. Again, the robot will not be running at full speed. I'm running it in manual at the moment here. You'll see it's kicking it right into run mode. And now it's found this part in this new image. So it's going to go ahead and come down. And I do not have a drop point set up for this either. But you can see that it has gotten the part there. So go ahead and let that go. So robot was able to pick up the part. As you guys can see, you could add more points, get more pick poses, and the robot's just going to use those, and they'll have to work with whatever you're trying to do when you drop this off. That's the edge algorithm. So I'm going to jump into some of these plugins real quick. I'm going to demonstrate these one by one. So first one's going to be the circle algorithm. I'm going to keep using this part for the circle algorithm as well. And the reason is with the circle algorithm, you're looking for a primitive. You're looking for a circle. This one has a nice circle right on the center of this part here, right on the tip. So basically, with plugins, you are looking, everything is going to be in an XML file. So when I've set this up, again, I go here and I select my circular shape. The only parameters I have here are my localization parameters. I don't have anything about the part. The reason is it's all in an XML file in the background. There is something in the roadmap to integrate these parameters to PLB, but currently we are going to have to go to our C drive, program data, SIC, PLB, default workspace, job library. And then you'll see this list of all your jobs here. And so in this case, I'm going to pick my circle job, and I'm going to look at my plugins folder. And so these are all my installed plugins, and they are the particular XML file associated with that algorithm for this job. So if I go ahead and edit this, and I like to use Notepad++, just colors are nice, you'll find a whole bunch of parameters that are what are determining how this plugin works. And so generally, with plugins, it's the idea of them is we can develop a localization algorithm outside of the development cycle of PLB. And it doesn't have to be us. SIC has several plugins, like I've mentioned, but an integrator or an end user can develop their own plugin. We do have a development kit, so there's nothing stopping you from making your own localization algorithm and using PLB as a wrapper around that to deal with all the robot side stuff. If you know how to process a 3D point cloud and do what you want with it. So with that said, our plugins are always sort of organized like this. We have our image filtering information up here. We'll have some parameters for the part itself here. And then we'll have some debug mode stuff down here. I have my debug turned to true right now. That way I can actually see what's going on with the plugin itself. I have this set up for my connecting rod here. So I'm looking for a cylinder height of 15 millimeters. And that inner radius is going to be 27.375 millimeters. That is the inner radius of that connecting rod. The outer radius, there's a small lip on there, and that's why I said it's my outer radius. That's at 32.5. And then I actually didn't end up playing with these at all. These are all set to default. So I could smooth the image a little bit. I could do some thresholding of the edges, score candidate thresholds. There's some things we can do to parameterize our image before we actually evaluate it, but at the moment, the defaults seem to be working well. So if I go back here, again, this is very similar. I've set up my localization here within this XML file. I'm going to jump to here where I've already set up my tool. Again, poses. And the difference here with poses is that I don't have an image to work on. So with the Cad algorithm and the edge algorithm, you're either using the Cad file to actually visualize your pick pose, and with the edge algorithm, you have the reference image to visualize your pick pose. In this case, you're only working with just a blank space here. So when we do a localization, you'll see a coordinate system pop up. That coordinate system, if I turn off local transform, is associated with the one you see here. So if I move this up, you can see this origin here. That's where my coordinate system is looking at when I get a localization. This is what I'm going to be referencing. And so I'm putting my gripper in reference to that localized coordinate system. It'll probably make more sense in a minute here. So like I said, you always have a bin to localize. I just have to set this back up. And I'm going to go ahead and go to my analysis mode. Again, I'll take a picture, just make sure that this is the most recent. And I'm going to localize my bin. If I do a localization here, you'll see it finds a circle. Now, this again is the coordinate system that I'm talking about. So my pick pose is going to be relative to this coordinate system, just like I have it relative to this coordinate system. So it's going to be a little bit lower in the Z, basically, than this coordinate system the system is finding. When you look for that debug, this is the debug right here. So it's showing me exactly what the plugin has found. These are all things that I can use as pick poses. And I also have a nice debug file that gives me more data as well. If I were to go back to my PLB folder here, you'll see I have circle shape debug as a system I can bring up. And it will give me a lot of information about the particular thing it's found. So whether it's the tilt, it's the radius that it's working with, anything like that, it's giving me information that I can use to make my my plugin work better. So if I click collision here, you'll see it comes down. It's going to show me my position relative to that coordinate system, just like I have in my pick pose. And so the one thing you'll notice here is this localization is not orientated with the part. The circle algorithm is looking for a circle. It does not know how to, it basically assumes that your circle is concentric and that it's fine for you to pick it up any which way. It's going to try and find the best way for you to pick it up, but it's not going to know any orientation of any other features. So if I do other ones, you'll see it can find other ones. It can pick them up. So that's really all it takes, though, to set up my circle algorithm. Again, we could run the robot with this. There's nothing stopping us, but I'm going to go ahead and move on and show you guys the next one here, which is going to be our predefined box. So with predefined box, I'm going to go ahead and remove some of these parts. I'm going to throw a couple of other parts in here. So I have some smaller boxes that I just threw in here. Take a picture so you guys can see what's going on. So I have these boxes, just small, thick boxes that I've been working with. And so same idea. And this is, it's all going to be in XML again. So I'm going to go back here, my default workspace, my job library, my predefined box. And I'm going to jump in here and open my predefined box XML. So again, what predefined box does is it's looking for a rectangle. And that rectangle has to be a specific predefined length and width. So that is set down here. If you see predefined width, predefined length. In this case, I'm working with 62 by 102. That's kind of in millimeters. And I'm allowing a 15% deviation from that. Depending on your camera, what you're using, that number could change. I just found that was a good number with this particular box that I'm using. It can bow and reshape itself. That's not the nicest box in the world to use. So, other things that I have in here. So I have smooth in-painting radius. That's basically how much am I going to smooth my image. In this case, I don't want to smooth it very much. I would start to lose my box-like properties, so I'm going to smooth the image. I can also deal with roughness, tilt, my neighbor radius. That's a big one. Neighbor radius is basically how far will we jump over cracks and crevices to connect regions. So with a box, if you have boxes butted up against each other, you probably want a lower setting for this than a higher. That way it doesn't jump over that small little dip that it's going to see when they're butted up against each other on a pallet, for instance. Or ingots is another one where you have them meshed together. You would want this on a lower plane there. So same here, noise tolerance, curvature threshold, all these have to do with your application. We do have an integrated plane segmenter. You can turn this off if you don't want to use it. It's just how it segments the planes throughout the image. Again, down here, we have the length and width and our size variation, and then we have how we're going to score this. This is our priority. This is our priority settings here and our confidence settings here. So we're able to change how we're scoring this. If we wanted something where we're only caring about the highest Z, we would essentially set our height weight to 100, and everything else would be 0. That way we always get the localization that's the highest Z. Likely you would do like a 75 with that, maybe a 25 with confidence in an actual application. And just like the other one, we have our debug log and our debug view turned on. Normally in production, you would want to turn those off. So go ahead and close this. Again, just like the other one, you'll figure out any sort of score thresholds. I do not have a gripper set up in this one. No pick poses. So I can set those up real quick. So what I'll do, go back to my configure mode here. So you guys can see this process. Your CAD model is going to need to be, turn that to a 1. CAD model will need to be a step or IGES file. Those are 2 types of files that work for this. So, moment here. I remember where I put my specific files for this. I'm not sure. So I'm not going to bring in a gripper. So I'm going to leave this alone right now. So again, I do have my bin already set. I'll show you guys on the flat region that the robot can move to the part. So if I go to Analyze, take an image, localize my bin, and go ahead and localize my part. You can see it can find it up on the angle, or it can find it sitting down here. So it's very capable of finding your parts there. You'll see in my debug view here, I am finding all the parts. They're all in green. When they're in green, that means they're actually a good localization. If you saw an orange one or a red one, it means it didn't meet some part of my my algorithm. So I throw a larger box in here. You'll see is it will show up in orange most likely, because when it's orange, that's going to mean that I'll show you here. So orange, it means it was able to create a box pretty well. It met my parameters for the region growth settings. It met these, so it didn't have too much noise. It wasn't too rough. The tilt wasn't too much, but it did not meet my predefined length and width. That's why it's in orange. If it was in red, it means it did not meet these region growth settings. Now, if you want to know a little bit more about this, like I said before, we can go to our debug settings here. We have our predefined box debug. I want to bring this up. You'll see all the different ones I'm getting that are valid. See, it's valid here. If I go to the one that's invalid, that's that larger box I threw in. It tells us that it's the wrong size. And it's going to even tell us what size it is. Here's our length and width right here. Obviously, this isn't completely accurate. It's very close, within millimeters. So if you see these ones, I'm looking for a 62 by 102. It's telling me this is what I'm finding. In this case, I'm finding a 143 by 168. So that's not what I'm looking for. If I was using my flat region, though, I'd be able to find that within a range instead of just using my predefined box. So we're going to move on to that one here. All right, so my flat region here. So again, same idea. This one already has my grippers in it. And I'm going to go ahead and open up, I do have to jump back through here. So going back into this job, we got our flat region. We're going to bring this up. And this looks very similar to our predefined box because it's pretty close to the same thing as a predefined box. We're still looking for a rectangle, except for the differences in this case. We're not looking for a predefined rectangle. We're looking for a range of rectangles. And so the main difference is going to be in my rectangle size settings right here. And so in this case, I'm looking for any box that's going to be bigger than a 45 by a 45. That's really all I care about in this. My -1 here means I don't care. You can go as big as you want. We can also set a ratio. So if we wanted to set a specific length to width ratio in the min and max, we can do that as well. That way maybe we're not finding boxes that are really long for some reason in our application. So this again is already set up. I have used mostly default parameters. The only thing I changed is my roughness tolerance here. That used to be a 1. I set it to a 0.75. So if I go ahead and run this, you'll see it find my bin. And I'll run my localization. You'll see it finds that large box this time. I do not have my debug turned on, so let's go ahead and turn that on so you guys can see that. Go ahead and run this again. Now my debug comes up, and you can see that I'm finding all these different items here. Now, it's not finding this item. That might be from my tilt threshold. Maybe I need to change some of my smoothing settings. There's a couple different things we could work on for that. In this case, I'm going to start with my noise threshold, though. Just try turning that to a 1. It might be something that, you know, as time goes on, you're able to find everything a little bit easier. So still not finding it. That's something that we could work through. Basically, you saw on the predefined box, it was able to find it, so nothing stopping us there. So again, we found this. It's going to show us our pick point here, which is just going to be pointing to it more or less. We can look at others as well here. So there's other parts that we'd be able to look at. And that's pretty much how you end up using the flat region. You could end up with a bunch of different box sizes. Again, it could be ingots. It could be anything else that has a primitive rectangle built into it. We have this for pipe. We have this for brake discs. It's all over the place for that. So I'm going to go ahead and show you guys that it can, in fact, find this one. And it will move the robot to it, just to point to it here. So just like before, it's moving the PLB system into a run state. It's going to have my robot. Oh, one moment. Not change the job correctly. All right, I'll try that again. I had accidentally changed it back to the flat region, the edge job instead of using the flat region job. So you'll see here, robot's going to move to this specific point, and it's going to point to this part. So can't pick it up because obviously I'm using fingers and I do not have a suction cup, but it kind of proves the point that the robot is able to make it to the part. So we could throw more parts into there. You guys can see all the different ways that it's going to find things. So I threw a few more parts in. If it finds one, like I said, that's not 45 millimeters big, it's not going to use it. So go ahead again and do this. See, this box is very different size. This box is actually smaller than 45 millimeters, so that's why it's not finding it. So you'll see, very robust algorithm for doing this sort of work. And you could strap these algorithms together to really, make a good application. So in the case of the connecting rods, you could end up using the circle algorithm and the edge algorithm. And if you have a somewhat structured bin, that might be all you need. So normally you're not going to do a fully random bin with these plugins. You're going to be working with somewhat structured bins. But even in this case, this is a somewhat structured bin. I'm not expecting that the parts are going to be up on crazy angles or anything like that. They're generally going to sit flat. So that's the definition of a somewhat structured bin. So now, just so you guys can see a full running system, I am going to switch back to the CAD job here for my connecting rods. I'm going to go ahead and throw them in here. And we can go ahead and at least start taking questions here, Lisa.
Awesome. Thank you, Nick.